Are you ready to blast? Of course you are. Blast, there you go. That's the website. Basic Local Alignment Search Tool. This is the most successful DNA search engine that exists in the world, and also protein search engine and also RNA search engine. And the nice thing is you don't have to differentiate between RNA and DNA. You can put them all in as if the U's are T's. So you just use T instead of alternating, or whatever. You can feed in U's and it'll figure it out, I think. Yeah. So there's 4 different flavors of BLAST. Here's our nucleotide, BLASTX, T-BLASTN, and Protein BLAST, depending on what you want to search and what you want to use. If you don't remember, look right underneath. You got nucleotides, you want to find nucleotides. Okay. You've got nucleotides, but you want to translate those nucleotides and find proteins. Easy, no problem. You got a protein and you got a giant pile of nucleotides and you want to translate every nucleotide in that pile and see which of them could make a protein like the one you fed in. Oh yeah, that's T-BLASTN. That's my favorite blast. And you got protein, you want to find protein. Hey, protein blast, that's where you go. So let's nucleotide blast ourselves and see what we get. Boom. Okay, interface of all these tools is going to look like a big search box. And essentially you are just Googling at this point, and except that you're Googling nucleotide data. So I'm pasting in some nucleotide data, and you can see here you can click between the different types of blast. They're all right up there. T-BLASTX is like a combination of T-BLASTN and BLASTX. And there are other variables down here. You can give it a title, or you don't have to give it a title. You don't have to put in the nucleotides if you have an accession number, for example. You can just put that in here and it will search that accession number. What are you searching against? So this is your unknown, which they call a query. It's like the question you're asking, what is this thing? The answer is going to come from different places. So the standard is the nucleotide collection, which is non-redundant. They've taken out all the duplicates of things, and they've just got one of each thing. It's like half a Noah's Ark of DNA sequences, basically. Down here, you've got all these other genome and different archives, basically, of other types of data. A lot of these other types of data will not be present in the NR database. So there, if you're searching for a different sort of thing, you're going to need to go to a different one. But if you're just trying to figure out what is this thing, this is a good place to go. All right, let's see. If you need to say, I only want to search in rabbits and hares, bam, you can limit your search. And it doesn't matter. It'll search only in rabbits and hares. If this is an exact match for something else, it will not find it. This is good for cutting down data or for cutting out unwanted types of data. There are models, XM and XP, that are based on partly inferred data. Useful, but potentially you've got more errors than that kind of data. You've got uncultured or environmental data. That's like, data from the bottom of my shoe. Somebody sequences everything that I've stepped in all day long. You can do that. People do that sort of thing. So we don't really know what organism it's from, but we know roughly where in the world it's from, and we can infer a little bit about it based on that. You can limit to sequences from type material. So this is a way to limit it to things that are like the one example out of a group. So instead of looking for all coronaviruses, we'll only look for the named species of coronavirus, basically, not for all the different variants within those. And if you need to put in like a word and say, whatever, Jimmy found this, you type Jimmy in the box and you will only search results that Jimmy himself has recorded. There may be times when you want to do that. The other things you want to do, so different types of blast, and basically we're changing the statistical threshold here. So megablast for highly similar sequences, really fast, very good. But if you start to get some mutations, if you have more evolution, megablast is going to miss it. So sometimes you're going to go down to BLASTN, and hey, if this is a Goldilocks story and that's too hot and this is too cold, then right in the middle is going to be where you want to go, which is the discontiguous megablast that'll find exact things, but exact matches, but with some evolutionary shifting, like insertion and deletion. You're also going to want to get down here in the algorithm parameters. These are good. So max target sequences. Query is what you ask. Targets are what BLAST returns. And there are times when you may need to bump that up if 100 is not enough, because it'll shut the door after the first 100. Normally I leave this on, it's a statistical adjustment, and normally I would leave these as the default, but if you need to go in and change the way that some of these alignments are going to be calculated, there are ways to do that. You can definitely do that. And by default, it's going to knock out any low complexity regions. That's like a poly A tail, because they all look the same, because they're all just A. You can mask also just for the lookup table. That's another sort of internal thing that it can do. You can give it some options. If you have, you can set the word size that you're going to search, or in this case, there's our word size, or discontiguous word. This would be like a word with some gaps in it, would be this size. And there are several options there. And then bam, you hit BLAST and you leave it just a second and it's going to tell you what's going on. Now, if you run into trouble and you have an iffy internet connection, which we will sometimes have in the classroom or sometimes in my house, quite often in my office, what you can do is you can go back here to recent results. That'll show you everything you've been running for the last day or so. And then you can either type into this box this number, or you can just click it and it takes you back to the sequence. And so once that sequence comes back, it's going to tell us what it thinks our data is. And I'll do a separate video for interpreting a BLAST result. That's in just a moment. So for now, this is it.